Hello again. This is a continuation for exponent rules, picking up where we left off in the previous video. So how would you compute 3/4 squared? And we're going to do this literally first again because we want to explain where the rule comes from. Once you know the rule and understand the rule, then you of course use the rule because the rule is a shortcut. Literally, it means 3/4 times 3/4. The way we multiply fractions is straight across, so we would be multiplying 3 times 3 on top, which is 3 squared, and we'd be multiplying 4 times 4 on the bottom, which is 4 squared. And based on the rule of thumb that we said at the end of the last video, you really should work this out, and you should get 9/16. But the point is seeing what happens to the exponent. So what really happened to the exponent? The exponent went to the numerator and it went to the denominator. And so what really happens is if I have a fraction and I raise it to a power, that power is going to go to the top and it's going to go to the bottom. I am going to specify here that b is not allowed to be 0 because, as we said in an earlier video, you're never allowed to divide by 0. So this would not exist if that were the case. So b is not allowed to be 0. So in words, when we raise a fraction to a power, we bring the power to the numerator and the denominator. Okay? Now, pause the video for a second. I recommend that you do that. And try the top two on the next page. Okay, so we have 2/3 raised to the 5th power, and we have m over n raised to the 3rd power. If I use the rule, this should be 2 to the 5th over 3 to the 5th. And if I use the rule, this should be m to the 3rd over n to the 3rd. Okay? So we have a summary in bold right here, okay, of the rules we've seen so far. When you multiply like bases, you add the exponents. When you raise a base to 2 powers, you multiply the exponents. When you raise a product to a power, the power comes into all parts of the product. When you raise a fraction to a power, the power comes to both parts of the fraction. There is one rule that is missing from here, so I want you to add it in. This is in addition to the notes, so make sure you're adding this in. We're going to do the same thing, threefold. I'm going to show you where the rule comes from, we're going to write it in words, and we're going to write a general definition. So what if I had 8 to the 5th divided by 8 to the 3rd? What does this literally mean? This literally means that I have 8 times 8 times 8 times 8 times 8, 5 eighths being multiplied. And this literally means that I have 8 times 8 times 8, 3 eighths being multiplied. We know that 8 divided by 8 is 1. Okay, they will divide out and they'll give me 1. So this becomes 1, this becomes 1, this becomes 1. Okay, they're going to divide away. I'm really only left with 2 eighths, which we know is 64. Okay, but I'm left with 2 eighths. What really happened to these original exponents? I really wound up subtracting top exponent minus bottom exponent, and that's why I was left with 8 squared. So what are we observing here? Let's write it in words next. When we divide like bases, we subtract the exponents. And just to be clear, I'm going to put top minus bottom because order, again, matters. Okay, in mathematics here. Okay, and the general rule is if I have a to the m divided by a to the n, I'm going to get the results by doing a to the m minus n. All right. And this is as long as a is not 0, because you wouldn't be dividing by 0 again. Okay, so as long as a is not 0. All right. One last important rule before I leave you guys with the 4 at the bottom of the page. And I'm actually not going to give you the answers to those. I want you to use these as practice. Okay, we can go over them in our general meetings, okay, our meetings for class. The last one I want to do is the 0 power. And the way we're going to explore what the 0 power means, okay, is for me to give you a pattern. Again, mathematics is the study of patterns. As a matter of fact, this is going to take us through 2 rules, okay? This one pattern is going to take us through 2 rules, so it'll be pretty nice. Let's do this literally so we can explore the pattern that's occurring. 10 to the third literally means 10 times 10 times 10. I'm using tens because they're easy to calculate. I can just count the zeros, and I wind up with 1,000. 10 squared means 10 times 10, and we know that that's 100. I lowered the exponent by 1, and what that did was that removed a factor of 10. So in other words, I divided by 10 to get from 10 to the third down to 10 squared. What's 10 to the first? 10 to the first is 10. How do I get from 100 to 10? What happened here? Again, I lost a factor of 10. I divided by 10. What does that mean is going to happen to 10 to the 0? People are always tempted to say, oh, the answer is 0. Can you divide by 10 and get an answer of 0 here? Is that going to maintain the pattern? No, that's not going to maintain the pattern. 10 divided by 10 is 1. And this actually helps to explain why in exponential functions, the a value is the y-intercept, because anything to the 0 power is 1. Okay, so this is a very important fact. Okay, we just saw that a to the 0 equals 1. All right, that's true all the time, as long as a is not 0. We have to say that because we wouldn't be allowed to divide by 0. This pattern would not make sense, okay? 0 to the 0 is undefined. We can't do that, okay? That's the one exception here. But I will be saying, anything to the 0 power is 1, all right? With your knowledge that there is this one exception, okay? But anything to the 0 power other than 0 is 1. That's a very important fact. Let's keep up with the pattern to explore the next rule. If I keep dividing by 10, 1 divided by 10 is going to give me a fraction. It's going to give me 1/10 or 0.1, depending on if you convert to a decimal. So this is going to give me 1/10. If I divide by 10 again, this is going to give me 1/100th, or if you convert to a decimal, 0.01. Notice how, because it's division, it just keeps getting tinier and tinier and tinier. The decimal just keeps moving over one time, every time. This shows us that the base really winds up getting flipped down to the denominator because I just keep dividing. And so the last rule that we're going to see in this video is if I have a number a to the negative power, so let's say a to the negative n, all that negative sign tells me is that I've now divided, okay, below 0, And so I'm turning this into a fraction. This will be 1 over a to the positive n. And so a negative exponent simply tells you to flip this over. Okay, so that's what we're going to be dealing with probably in the next video as well. So I'm leaving these 4 problems, the last 4 problems in the packet for you to do, and please ask me any questions if you have any during our meetings. See you in the next video.